That was in the twist there. Yeah,
And if you kind of parallel what we've been doing with our multivariable functions to kind of how you got exposed to two variable functions, in Calc 1, you learn about limits of two variable functions. The basic premise of a limit in two variables is as I get really, really, really close to a certain input, is it true that my output is getting really, really close to a certain output? So I just drew a picture in which the limit as x goes to a of whatever that function is equal to b. Miraculous. In two variables, there are different situations in which you might not have a limit. In this case, the limit as x goes to a from the left of this function is equal to b, but the limit as x goes to a from the right of this function is equal to c. Because b does not equal c, we would say the overall limit, so the limit is just x goes to a, the limit is just x goes to a, does not exist. Other ways that a limit might not exist in 2D, you could have your function soaring off to infinity on one side, but negative infinity on the other side. So the limit from the left doesn't equal the limit from the right, and so the limit on each side does not exist. Okay, so that's a little reminder about 2D functions from Calc 1. Well, now that we have a multiple direction, a multiple input surface, your limit has to be the same from infinitely many directions. You don't just check left and right. I have infinitely many directions. So if I were trying to find the limit as x went to negative 5, 10, okay, I'm approaching the point, negative 5, 10. As I approach the point, negative 5, 10, I have to be approaching the same thing from all points, from all directions, from all points, for the limit to exist. And so this limit, remember how limits have to be exact, so from my Excel spreadsheet, I can't say the exact, so I'll put squiggly equals, all right? So the squiggly equals looks like it's approximately 9.28788. All right, so if you look at the chart in your notes, you can read the numbers better, but if you look at these numbers, all of them seem to be heading to the same thing. They're all heading to negative 9 point something. They all were heading to, the same value. So I would say the limit exists, and it's I could put an exact equal sign, because whatever that number is, it is what you get when you plug negative 5, 10 into a function. Okay, but in multivariables, you can't just check a certain amount of directions. Technically, the idea is, your limit exists if I can come at that point from any direction and I'm approaching the same value. So, imagine, coming up the hill to that point from any direction. If you're approaching the same point, then your limit exists. Honestly, for the surfaces that we're going to study, for the most part, your limits will always exist. We're going to deal with continuous surfaces, but technically you can have formulas that cause you to have sheets of like asymptotic sheets. Like you could have a cliff, like picture a cliff, that would be kind of like an asymptotic sheet. Or you could have, the function going to somewhere and it kind of levels off from one direction, but from another direction, it's, leveling off down at some other spot. So goofy things can happen and limits don't always exist, but, the most important thing for you to know is that technically a limit exists if you check from all directions. Okay, so you're supposed to be checking from all directions. In this example down here, again, I built these little charts in Excel, so how I did that is I just carefully skipped by certain amounts in the columns and in the rows, and then I programmed each of these to be the function. And it takes a little while, but that's how I did it. Okay, so for this example, this generic example, we're finding the limit as x, y goes to 0, 0, and the function itself is defined at 0, 0. I have a piecewise function technically, and the piecewise function is telling me that when I plug in 0 and 0, I get out 0. But if I look at the Excel spreadsheet and I picture coming in from different directions, I will notice that all of my inputs are not heading to the same thing. So if I come in from this direction, it looks like I'm approaching 1.5 until at the center is 0. If I come in from this direction, it looks like I'm heading to negative 0.57 something. So if you follow different paths of numbers, like I come in this direction, I'm heading to negative 1.5. I come in this direction, I'm heading to positive 1.5. If I come in on that diagonal, I look like I'm approaching negative 0.57. So this is an example where the limit does not exist. As I try to approach 0, 0, the limit does not exist, because as I come in from different directions, I'm creating paths that are leading to different values. And if you look at the function, you can kind of see if you try to plug 0, 0 into the original function, you have an indeterminate form, and it's it's just from one direction you're getting different values in other directions.
So like the line,